Welcome to Griffy Lake Nature Day. We hope you're ready to watch and learn as we explore our local environments. Remember, you must follow along in your student journals and use the materials provided in your Nature Day activity kits to complete today's lesson.
Welcome to Griffy Lake. This is the Aquatic Odyssey station. I'm Dominic Hebner, a naturalist with Bloomington Parks and Rec, and we're going to be going over microscopic organisms. But before we get that far, I need you to get out your journal. Aquatic Odyssey is going to be first in your journal. You'll also need your key, your microscopic organisms key, and a writing utensil, and then if need be, maybe some crayons if you're into it. So following along in your journal, you'll see a set of terms, and it'll have a word and then it'll have a blank space next to it, and we're going to work on some definitions so that way we can better understand what it is we're about to do in the following activity. So our first term is micro. And what micro is micro means organisms that we can't even see. They're so small we need assistance. So we would be using a microscope if you were here with me in person, but for those of you at home, you're going to be using a digital microscope. So we're going to have some images for you that have already been imaged using a scope similar to that. Now, the next term is macro. So macro are organisms that are large enough for us to see. So these are going to be like small flies, larvae, little crustaceans, small invertebrate organisms that we would also find in our waterways. So our next word is phytoplankton. Phytoplankton are microscopic aquatic organisms that function very similar to plants. And they make up the lowest rung of our food chain here at Griffy Lake. And our final term is zooplankton. Zooplankton are also microscopic organisms, but these are similar to animals or protozoa. And then our final one is a question here. This one isn't a term. It should say, how can we as ecologists use food webs? So as you learned in Fish Frenzy, food webs are kind of how all the different organisms eat each other, essentially, or how energy moves from the bottom to the top. So it's the exchanging of energy and nutrients amongst organisms. As we said, phytoplankton are at the bottom. Our zooplankton would be eating them, and then we'd move up into insects and fish, and we'd just keep going up and up until we got to the very top, maybe us. But as far as how can we as ecologists use those food webs, think of it this way. If we came to the lake and suddenly we were looking through the water and we noticed there weren't any zooplankton, right? Then we might be able to use that to infer, okay, if we're missing all our zooplankton, what's happening to our fish populations? And we can go from there. So we can use food webs to go forward and backward to kind of evaluate the health of our ecosystems. Now that we have all of our definitions and we understand how food webs can help us as ecologists, we need to look at some of these organisms so we can kind of understand what's going on in our water here. So if you were here with me, you'd be using this microscope to look at water samples to try to find our tiny friends, but today you're not. So first, I'm going to start off by showing you how I collect these water samples, and then what you're going to see are pictures of what we see through our microscopes, and we'll get on to identifying those after that. All right, so this is how we're going to collect our microorganisms. So what this is a little net. Down here it's got a really small container. It's got very fine holes. And what we're doing is we're going to sink this as far down as I can get it without it touching the bottom. And then I'm going to slowly pull it back up. We're doing this so that way we can make sure we're getting microorganisms from the very bottom of the lake all the way to the top. So we'll do this a couple of times. Once this is full, we'll take it, dump it in our bucket, and then we'll do this, maybe 3, 4, 5 times until we get enough water that we can take as many samples from it as we need to look under our microscope. All right, so we're gonna gently lower this down, let it go all the way to the bottom, but we don't want it to touch, just as close as we can get. And then we slowly pull it back up. And then I like to let it drop down a couple more times just so we can scoop up any extra organisms down there. All right. Look at it, make sure our bottle's pretty good and full. Then we grab a bucket. We just let it out in there. And like I said, we'd do this a couple times so we had plenty of samples. If you can see this, there's some little specks in there that lets me think maybe we already have something. We couldn't really tell, we'd have to look really closely, but on each of those little twigs and little pieces of leaf that are floating around, we have the potential to have tons of organisms. Now it's time to identify some of these organisms ourselves. So you're going to be looking through our microscopes, and you're going to be using that micro-identification key to try to figure out what some of these organisms are. You have 6 circles located in your journal. In those journals, you're going to draw the organism. You can do this with a pencil, you can color it in, draw it however you'd like, as long as we can tell what it is. And then below that, there's a question that's asking you to not only name your organism, but to tell us some of its characteristics. So let's go over a few examples of those before we get into actually looking at the species. So if you'll get out your micro-identification key, it'll look very similar to mine, but a little different. It'll have all the organisms on it. You'll notice there's algae, there are phytoplankton and zooplankton. These are the 3 categories of microorganisms. You may notice that algae was not in our definitions earlier, and this is because depending on the algae, some of them actually do fall under phytoplankton and various other categorizations. So we did not include those in our definition, but you may see some of those in our water samples. So a few characteristics you may notice if we look at the zooplankton now. They have unique body segments. Some of them have what appear to be legs. Some of them have little things that look like tails. We'll call those flagellum. And some may even have gills or almost what looks like a shell. So those are some characteristics you can put for those. For algae, notice that some of them have very clear linked sections that duplicate. So these would be multiple algal cells. And then you can list things about the shape, the color, any sort of characteristic that may help you in identifying these organisms. That's what we're looking for there. So what you're going to do is on the screen, an image will pop up. It'll be us looking through our microscope, so you'll see what we see, and you're going to need to pause that each time a new image appears. So that way you'll have time to identify it, draw your picture, and things like that. Once again, you'll see 6 of these, and you have 6 circles. So each one will need to be drawn and identified in your journal. Now that you've helped us identify some of the microorganisms here at Griffy Lake, it's time for us to create our own. So on the next page, you'll see a big open space, and what I'd like for you to do is draw your very own microorganism. Now remember, it has to either be algae, a phytoplankton, or a zooplankton. But you're gonna draw it, you can color it, or if you even wanted to go above and beyond, you could maybe even make your own at home using some paper. But even still, I need you to draw me a sketch of it here. So you're going to draw it, and then you're going to answer a few questions at the bottom for me. So you need to have your organism's name. You need to tell me what kind of environment that I could find your organism in. Maybe even list a few of its characteristics, and then tell me where your organism fits in the food chain. All right, so this is my example of an organism that I created. It's called the Dominicazoa. Its environment would be in the Amazon. It really likes that loose substrate at the bottom that's nice and decomposing, and it is a zooplankton. So in our food web, it would be above those phytoplankton, and that is what it would feed on. A few characteristics of it: it has some legs here, it has a little flagellum-like tail, and then a big body segment. And yeah, this would be my organism. So now it's time for you to draw yours. Make sure you give it a name, list its environment, tell me where it's at on the food web, and you can talk to me about any of its defining characteristics that you want to.
At this point, you should have completed your student journal pages for this lesson. Thanks for watching. We'll see you next time.